Here's number 19 from section 2.4. A particle moves along a line so that its position at any time t greater than or equal to 0 is given by the function s of t equals t squared minus 3t plus 2, where s, this function, is measured in meters and t is measured in seconds. So a lot of questions to ask here and a lot of good vocabulary and formulas to review. First, for part A, find the displacement during the first 5 seconds. So the displacement is nothing more than how much did the particle move in those first 5 seconds. So let's take a look at that. To find the displacement, we would want to know where the particle ended up at second number 5, and then subtract where the particle began at second 0. So let's get into this. S of 5 would be 5 squared minus, let's do this over here. S of 5 would be 5 squared minus 3 times 5 plus 2. So that's 25 minus 15 plus 2. So that's 10 plus 2. This is 12. So 12 minus. And S of 0, I think it's clear to see you're just going to be left with the 2 at the end of the function, minus 2. So the displacement over the first 5 seconds is 10. For part B, we want the average velocity during the first 5 seconds. Average velocity is another way of saying average rate of change, and we know that that is the distance traveled over the time taken, the average velocity. Well, it's the same 5-second interval as in part A, so we already know the distance traveled is 10 spaces, and then we know that the time taken is 5 seconds. So the average velocity is 10 over 5, or 2, and that's going to be labeled as a rate. We know that's going to be in meters per second. Let's go to part C. Find the instantaneous velocity when t is equal to 4. Instantaneous velocity, or instantaneous rate of change, IROC, is asking us for the derivative. We want the rate at a moment. So we need S prime. So we're going to go S prime of t is by the power rule, 2t minus 3. And then we want to know what S prime's value is at t equals 4. So S prime of 4 is 2 times 4 minus 3, and 8 minus 3 is 5. And that's a rate, so that's also going to be in meters per second. Let's go to part D. Find the acceleration of the particle at t equals 4. Acceleration is the derivative of velocity, which means it's the second derivative of position. So we want S double prime of t. And in this case, it's just 2 by the power rule. So it really doesn't matter when we check it. S double prime of 4, or S double prime really of any input value there, is going to be 2. And that's a rate of a rate. So it's meters per second, or oftentimes we see that written as 2 meters per second squared. Next, part E. At what values of t does the particle change direction? So this is going to be when the velocity is equal to 0, because the velocity change from positive to negative or negative to positive will indicate a change in direction, moving forward to backward or backward to forward. So let's take the velocity function that we found in part C, S prime of t is 2t minus 3, and set it equal to 0 and solve. So this is going to say t is equal to 3 over 2, or 1.5 seconds. And that's going to be where we change direction. Finally, where is the particle when S is at a minimum? When S is at a minimum. So first of all, we want to know what direction we're going when we see the minimum value. And I assume that's going to be, and we should all assume that's going to be when our particle heads left, changes direction, and begins to head right. So we know where we change direction. Let's make sure if that's when we're going from left to right. So what is the value? I'm going to go over here for part F. We know that we have a change of direction when t equals 1.5. What is the velocity value to the left of that? In other words, what is the velocity at, say, 1 second? We would say 2 times 1 minus 3, that's a negative 1. And then further from 1.5 seconds to the right would be 2 seconds. What's the velocity at 2 seconds? That's 2 times 2 minus 3, and that's positive 1. So we have a negative value to the left of 1.5 second, a positive value to the right. So that confirms we are going left to begin, and then at 1.5 seconds, we eventually then go right the rest of the way. So question F is where? Where is the particle? Well, we know when this happens. It's at second 1.5. Where is it? Let's go back to the position function. S of 1.5 is going to be 1.5 quantity squared minus 3 times 1.5 plus a 2. So 1.5 quantity squared is 2.25 minus 3 times 1.5, that's going to be 4.5 plus a 2. And so let's see, if we put 2.25 and 2 together, we get 4.25 minus 4.5. So it looks like our answer here of where we are going to be at negative 0.25. And let me just check that in my book. And yep, that's going to be right. That's in meters. So there we are. We have our answers for part A, B, C, and D, E, and F. And that's number 19.